resistance between the terminals AB, RAB we need to find out here. So that is by using the star delta transformation. So what shall we do is, so if you by whenever the circuit is given, we need to observe the circuit diagram whether any series parallel combination is there. Suppose if the series parallel combination is not there, we need to identify the star part of the network and the delta part of the network we need to identify. So if you observe the circuit diagram, we have the one delta network between the nodes A, B, C, that is A, C, D. We have the one delta network. So this is a delta network 1 here, and other delta network we have here. So between these three nodes, so we have the two delta networks. This is one, and this is the two. So what we can do is we can consider the and as well as between the BEF we'll consider, and we'll convert this one into the simultaneously into the star network, and we'll do evaluate. First I will consider the first delta network between the nodes A, C and D, and later we'll do convert this one. So we'll consider the delta network. So between the delta network between the nodes, it's a ACD we'll consider. So how the network is there, the same way I am going to construct it, so that it will be easy for us to do replace the network back in the circuit diagram. So this is the node A and node C and node D. The value for the resistance is it's a 4 ohm, and this is the 10 ohm, and this is the 6 ohm, and the equivalent star network inside the delta we do construct. So here this is the value which is called as RC, and this is RA, and this is which is called as RD. So let us RC, and let us find the value for the RD. So RA is nothing but it's a product of the two neighbor resistance divided by the sum of all the resistance. So that is RA. So it is a 4 into 6 divided by the sum of all the resistance. It is a 4 plus 6 plus 10. So that is a 24 divided by 20 we'll get here. So similarly the resistance RC. The RC is nothing but it's a product of the two neighbor resistance divided by the sum. The sum remains same. So the product of the two resistances it's a 4 into 10 divided by 20, and similarly the resistance RD is equal to, so 10 into 6 divided by the sum of all the resistance. So let us find out this one. It's a 40 divided by 20. So this will become equal to the 2 ohm we'll get. And similarly it is 60 divided by 20, which is equal to the 3 ohm we'll get. And this is 20 divided by 24. This is 2 tens, or we can take 4 fives and 4 sixes. So it is 6 by 5 ohm, which will become equal to the, so 1.2 ohms will get. So 5 ones are 5 twos are 10. So 1.2 ohms will get. So this is the equivalent resistance we'll get between the between the nodes A, C and D. So similarly, let us find out the equivalent impedances between the node B, E, F. We'll consider the delta part of the network we'll consider. So we'll consider the delta part of the network between the B, E, F. So consider the delta network between nodes. So B, E, F will consider. So I'm going to construct the circuit diagram how it is there. So B, E, F will consider. So this is the node B, and this is the node EF. The values are 10, 15, and 20. So this is E and this is F. This is the value for E and F. So it is a 10, 15, and 20. So this is the resistance which is 10 ohm. This is 50 ohm, and 20 ohm is the resistance here. Yeah, same resistance we have. Now let us construct the star network inside this one. So this is the star network where we have. So we need to find out the value for the RE, RF, and RB we need to find out. So the value for the resistance RE, RB, and RF we need to find out. So the value for the resistance RE is nothing but it's a product of the 20 into 10 divided by 10 plus 15 plus 20. So this is 20 into 10 divided by the sum of all the resistance. It is 20 plus 10 plus 15. So similarly, for this one, RF is nothing but 20 into 15. So 20 into 15 divided by the, it's a 30 plus 15 is 45. And similarly, RF, sorry, this is RF and RB. So this is RB. So RB is nothing but 10 into 15. So 10 into 15 divided by 45. So this value is 200 divided by 45. The value for the resistance will be, so 200 divided by the value is 45. So it is 4.45. We can consider 4.45 ohms. And this is 20 into 15 is 300. So divided by 45. So 300 divided by 45. So this value will be the 6.67 ohms you'll get. And similarly, this is, so 10 into 15 is 150. So divided by 45. So 150 divided by 45. So this will be the 3.34 will get 3.34 ohms will get. So these are the impedances between the node RE, RB and RF will get. Now what we can do is, in this part of the network, so between the ACD and between the BEF, we can do replace with the equivalent star one. So I'll construct the network without this delta part of the network by leaving the delta part of the network blank here. So we'll do replace with the star network here. So we'll consider that one. So what we'll do is we'll consider this is the node A and this is node, we have the resistance between here. So between the nodes, let us look into the circuit part here. So just I'll take this one for the reference here. Later we'll do replace there. So between the node C and E, we have the resistance, which is a 6 ohm resistance is there. This is the C and E, and between D and E, D and F, we have the 9 ohm resistance is there, and this is the node B. And here we need to do replace with the network, which is a star network. This is the star network we are going to consider. So here the star network is there. This is the star part of the network. And here also we have the other star part of the network. So this value is RB, and this is RE, and this is RF. This is RE, RC, and RD. So let us substitute back this one. So the value for the RB, which is so 3.34, and the value for the RF, it is 6.67 ohms, and the value for the RE, so the value for the RE is 4.45 ohms. And here, so similarly we have the values for this network. So I'll replace the network back here. So this is a problem number 3. So I replace the network back. So we got RA 1.2, RC 2 ohms, and RD 3 ohms. So RA 1.2. So this is a 1.2 ohm, RC and RD. So RC is 2 and 3 ohms. RC is 2 and R3 is 3 ohms. RD is 3 ohms. Now if you look into a circuit diagram, we can see RC 6 ohm and these two are in series, and this one 9 ohms and 6.67 ohm are in series here, and we'll get the equivalent resistance. So this part of the network will become equal to like this. So this is the resistance RA, which is equal to the 1.2 ohms. So in series with these two will come in the parallel connection. So we'll get like this. So this is 3.34, and here 6, 2 and 4.45 will become 10, 12.45 will get. And here 9 plus 3, 12, 12 plus 6 it will become 18.67. So we'll get as the 18.67 ohms we'll get. And these two are in parallel in series with this one. So this is between the nodes A and B. So if you find out the equivalent resistance, we'll get, so between the A and B, so this is 12.45 is in parallel with the, we'll calculate the equivalent value. So parallel with the 18.67. So that is in series with the 1.2, in series with the 3.34. So we'll get the equivalent resistance will be equal to the, so 12 ohms will get here. 12 ohms is the equivalent resistance between the nodes R, A and B. So this is R, A and B. The equivalent values. So it is 12 ohms will get here. So this is how we can use the concept of the star delta transformation in order to convert a given complicated network into the simplest one, and we'll get the